TEK-TOK.
Great. So thanks for being with me today. This is TBC-INTV TEK-TOK. And our guests today are Alex Kozakov of NATRION and Ian Faulkner, who is going to talk to us about energy storage and off-grid storage applications for local power solutions. I'm John Tuck. I'm president of TBC-INTV. I've quite a bit of experience in the energy storage arena. Started in fuel cells, then co-founded a company who produce supercapacitors, now called C-Ion. And I've had a lot of experience with a company called Empty Power. But today I'm representing my own consultancy, Silent Koala. Alex, if you want to just give us a brief introduction for yourself, that'd be great. Thank you.
Yeah, no, thanks for having me, John, on TEK-TOK. I'm Alex Koskov, co-founder and CEO of a company called NATRION. NATRION's a solid-state electric vehicle battery developer based in Illinois in the United States. We're just near Chicago, and yeah, so we focus on developing components for EV battery cell manufacturers towards transitioning towards safer and higher performance solid state batteries. My background is also in electrochemical device material development, and I started this company 4 years ago, and we've been at it ever since. So thank you very much for having me. Yeah.
No, thanks, Alex. That's great. Thanks very much. Ian, really great to have you here, and looking forward to you telling us about what you've been up to, because I know we've had lots of discussions in the interim. So floor is yours.
Well, my name is Ian Faulkner. I'm the managing director and owner of one or two, a few companies. The main one at the moment is a company called Signal Solar Energy. This came about from a very long, nearly 40 years automotive industry experience, which went to electric vehicles probably about 20 years ago when they first started developing them, some in Japan, but mostly latterly in China. One of the companies I worked for was a company called Sinopoly, who owned a car company called FDG, which is actually in America. Actually, they supply FedEx in America with vans and things, all electric vans. I found out from the company that they also did domestic storage and industrial storage and commercial storage in a variety of systems and all over the world. Actually, an international company. I was looking to get involved. I have a small farm up here in Scotland, and I was looking to put some log cabins involved for tourism, and therefore being off grid was the idea. And I contacted Sinopoly and asked. And after, to cut a long story short, I ended up as a distributor for the UK, the Southern Ireland, and some other parts of Europe, because it seemed to me a very good idea and a hell of a good opportunity. So that's where it started about 3 years ago. This company started now, and we've been through the development process with the Chinese. It's basically in 3 phases. The first thing that they do is the domestic stuff, which is some things up to 10 kilowatt to 20 kilowatt storage, domestic house storage, powered by off-peak cheap electricity or solar panels, or wind turbines, or whichever. There's 4 inputs on the inverter, so you can charge it any way you like, or any way possible. And that's where we've actually started bringing the company forward. The next phase to that is the semi-light, up to about a megawatt in containerized storage for on-site, either temporary power or for permanent power on floating balancing grids. And again, for small domestic situations, or have half a dozen houses at once, that type of thing. We also they've just developed and they've just brought to market a cabinet which is actually about 30-40 kilowatt storage, which has been designed specifically for China, but it does have applications here because they're suitable for flats. So you can get flats involved, so you can put one on each ending of the flat and do 4 flats with it. So that's where we are. The other big stuff that we are doing, we are talking to the Army. We're talking to 2 of the main power suppliers in the UK. The reason is that they all run diesel generators and their emissions are poor because of the off-peak times of being diesel. They run these things 24 hours when they put temporary power in, and of course when that goes on to like standby or just a very low load, the emissions are not high. They're not good at all out of diesel engines. So they're looking to make them hybrid. So there's several hundred of these being talked about at the moment, and they're going to be developed by the Chinese as we progress. Other major things that's happening around here is that there has been 6 islands picked around the UK. And I was actually quite surprised to find out that the UK has nearly 300 islands around its shores. I didn't realize there was quite so many. I knew there was a few, but I didn't realize there was quite so many. And 5 of them have been chosen by the government to be totally self-sufficient in power. One of them is the island of Islay, where I have, which coincidentally I have some relatives from. They have got permission now to put 2 wind turbines. They're putting a tidal generator somewhere around the island. All the domestic houses are going to 10 to 14 kilowatt battery storage, supported by the government, and it's going to be powered by solar panels and use of off-peak. And the main reason that this is there is because that on the island they have 14 whiskey distilleries, which is quite substantial. That's their main industry on island of Islay. I mean, it's all exported. Well, most of it anyway. But when they actually go to the process of making it, the power consumption is enormous, and the feed comes from the mainland, and the cables are now just not big enough to take it. So they all have to take it now in turn. And then on many occasions, all the domestic houses, of which there are about 2,000 inhabitants, I think, between 1,500 and 2,000 inhabitants on the island, they just lose power because they're actually cooking mash to make whiskey, and that's it. And if too many of them do it at once, there's no power. So they're looking at the houses being independent and charging them independently from their own sources off the island. So that's what's happening. And there's 6 of them. I don't know what the other 5 is yet. I haven't found out the other 5, but I know one of them. We've been asked to quote for the domestic packs in the houses, and they're also going to do larger storage of about 1 megawatt at each distillery, so that when there's off-peak and there's excess power, they will store it before they go into the process. Process only lasts 3 or 4 days when they're actually making whiskey. The rest is sitting looking at it for years. But the process of making it's quite power consumptive. So anyway, that's where we are. That's what we're doing. We're just about to launch in February. We've got 7 salesmen in the country just about to start. We're just doing the warranties at the moment. That'll be ready in the next week or 2, which is all underpinned by UK companies, which is unusual. Most of them, most people that sell them go on the Chinese warranties, which aren't really comparative with Europe. So that's really it. I've got the salesmen ready to go. They're all in training at the moment. We're going through product and they're testing it and playing around with it and that sort of thing. So they'll be on the road in January. And that's it. The next big thing we've got to do is get the technical backup right. So I'm looking to get a couple of technicians involved that can, look after things if they go wrong and fix them, and warranty guys, that type of thing. So that's where we are, John. What do you think of that?
Absolutely fascinating, and it's in line with something I've been absolutely curious about, or very much in favour, and that is in so much as getting off grid. I think that what's clear is that the national grid is a lumbering giant that was put in place some decades and decades, if not 100 years ago, and it really does struggle to keep up with the demand, and I mean, not even thinking about the island situation, but even in the UK in general. So, I think one of the first instances I saw publicly of this type of arrangement happening was actually with Tesla, where Tesla said that they would put in solar panels and a storage system in order to charge the cars up, because from my understanding, if everybody in your street, assuming you live in an average sort of street, had an electric car, then everybody in your street would have to turn their electricity off in their house for 50% of the time in order to sustain the energy requirements for the cars. So for me, this is a really exciting project and a really exciting move forwards into a situation whereby we're less reliant on national grid that isn't necessarily any longer capable of supplying our requirements. So yeah, very exciting.
The major things that we are finding that we need to deal with, and we are trying to deal with that over the next few days with our team, is that it's an educational thing. There are lots of this equipment on the market, and certainly people and certainly installers look at it from a price point of view, and we get all the time saying, "Oh, this you're more expensive than this one," and all that sort of thing. But for the common person that's going to put this on their house, they're not really up to the domestic electrical setups that they can have and how this thing actually works. And what you really have to, so what we're trying to do, it's a lifestyle thing too. So it depends when they're in and when they're out and when they're at work and when they're at school and all this type of thing, as to the power usage of a particular property, and whether if they have an electric car, whether it dumps into the car at night and all this type of thing. And you can do it. The machines that we deal with now, with its 4 inputs and its 3 outputs, actually has an output direct onto car. So what basically happens is that if the cycle starts at sort of you can actually tell your power companies in the UK when you want your off peak, but it's between 11:30 and 1 a.m. So at 11:30 at night and 1 a.m. you can say, well, start me at midnight and it will go to 7 in the morning, or you can start at 1 o'clock and it will go to 8 in the morning, or whatever. You can pick that kind of period of time, again depending on your lifestyle. The off peak then comes in. Then the machine looks at the battery to see what's in storage, and the battery will be down because it's been used during the evening. The off peak then starts charging it up. It then also goes direct to the car through the battery, so it'll charge the battery first, and then it dumps the rest onto the car, and everything else it runs during the night. Like in here in the house here, I have a very low electricity cost just because of the batteries. If you work it right, I don't do any. There's no laundry done until it's 3 in the morning. It starts automatically at 3 in the morning. The dishwasher comes on at 2:30, and that's that thing, and it's all there done in the morning. But you have to plan it at night to run it, and that's all direct off the off peak. So the net result is that in the morning, when the off peak shuts off, the solar panels then come on board and start topping up the battery automatically. And I've then got at the moment I've got 10 kilowatts in the house, and that's enough to run this house all day and all evening, not including heating and not including hot water, because they're best left on the off peak or on the mains because of high demand. But the rest of it runs. This machine's actually running at the moment. The screens and all the videos all running off the battery at the moment, and it just sits all day. I usually end up with about 2 kilowatts at the end of the day, which is about average. It's about 8 kilowatts a house a day on domestic settings, so on domestic usage. So I run about 8 kilowatts a day, and I've got 2 kilowatts at night, 10 o'clock, 11 o'clock, and then the off peak, my off peak starts at midnight, and it starts charging again, and the cycle keeps going, which means that I'm using everything that's been charged. I do have an electric vehicle, and it's charged overnight. It starts at about 4 in the morning, I think 3 in the morning, something like that. It clicks on, and it does a 4-hour charge. Keep it low, it gets more power than the batteries. I don't like boosting them, so and you have the time, so yeah, I'll let that happen. And that's it. Everything's ready in the morning again with a full battery, whichever source, and then the solar panels top it up. If you get a big hot sunny day, then by 5 o'clock at night, then you've got a full battery in any case, because the panels will do it again, depending on the amount of panels, depending on your house size and how strong the roof is, etc., etc., etc. So it's not a situation where you can say to somebody, you can have 10 solar panels, this inverter, that battery, and it all works wonderfully well. It really depends on the individual domestic setting and the life of the people that's in there, what you actually fit and when you actually use it and how you set it up. But it can be done. It's very, very efficient. Very, very efficient.
So Ian, it sounds to me as if, I think as you said, there's going to be a lot of education that's going to be needed
Education is a big thing
to the consumer. And I think that probably is going to be a big part of your sales force, is going to be educating people.
Just to sit down and explain to them, how they do it, how do they live, when do they go to work, when are they back in, what they're running, what kind of things they do.
So what they're going to need to understand fundamentally, if they're going to consent to changing their lifestyle, is what's in it for them.
That's right.
So what sort of savings do you make? I mean, how much do you roughly save by implementing your systems?
Before I switched the battery on, my power consumption, because I have offices here at home, and that runs all the machines, and there's more than one here. We have it at the back of the house. My electricity bill per month, before it went up heavily in this last sort of little turmoil that we have, it used to be about £60 a month, £60-70 a month. It then went up to 170 during this little current blip that we've got. I'm now back down to £30 a month. That's what I pay.
Right. So it is significant.
Because I'm running, and I run it flat out. I do, you can switch it on and off, and you can plug things into it, and you can, so if there's hoovering to be done, I say plug in. I have in the house two different circuits. I have the normal circuit that is on the mains, because if there's a battery failure, an inverter failure, anything like this, I've still got mains power, and everything just switches on to the normal power supply. But alongside those, I've actually bought them off Amazon. You can get little green sockets, which are really quite nice. I have those all around the house now, which comes direct off the battery. So there's a choice. If the battery is full and the lights are full on it, and there's hoovering to be done, plug into the green one, use it. Might as well, and then
So have you also come across voltage harmonizers which stabilize the voltage across the
most panels have them fitted now automatically, but that used to be an option when you bought the panels, a little thing on the side of it which does harmonize the voltage. But nowadays the quality of panels, the panels that they're telling me in China that the R&D that's going into panels are going to be the size of a magazine very shortly for the power outputs that they've got now with what's going on. So I've been told that don't stick onto the off-peak side of things for the moment, because it wouldn't be good for a customer if you got to go back 6 months later and say, well, if you'd ordered them now, they would be this size, and now they're that size on their roof, and that's for 20 years. So we're just saying take it easy on the panels at the moment. But off-peak works fine. Off peak, I would be down to about 40 if it was just off peak, £40 a month.
And just to paint the picture, Alex, Ian, like us, is a very busy man. He has very, very little time. So if you're able to orchestrate a situation whereby you have the time to manipulate your energy that way, then most people are going to be able to do that, I'm sure. So Alex, is that something you'd be interested in if it were available in the US? And is it actually available in the US?
Yeah. No, it's well, where we're at in the Midwest, I think not so much. Our electricity out here is pretty cheap, but especially you see this kind of stuff a lot, especially on the Eastern Seaboard, and where that's some of the older grids in the country, and also you're seeing it a lot in places like, for example, like Puerto Rico, right? So 5 years ago, I think 5 years ago, they had Hurricanes Irma and Maria, and the whole island didn't have electricity for about 8 months. And so they've been rebuilding by getting rid of the centralized power grid and just switching everybody to decentralized solar plus storage. And so they're going to be much more resilient now in the next hurricane. But yeah, so and the other thing is that at least in the U.S. we're finally starting to see well, again, I'm kind of more from the electric vehicle side, but one of the big things in stationary storage is reusing old electric vehicle batteries. So when the rest of, they literally take the battery pack out of old car. Oh, you see this like the old Nissan Leafs. A lot of them have kind of come to the end of their life, but the battery is still good to prop up against the side of a house and use for backup energy storage or something like that. And so, and that's I think that's going to be very interesting to see, because ultimately the economics are everything. I mean, as Ian was talking about, all the the electricity costs, and ultimately your payback period is going to be entirely determined on how much you pay up front on the battery. So if we could reuse EV batteries that are otherwise somebody's going to have to pay for them to get somehow recycled or just thrown out someplace, right? If we can reuse those and bring down levelized cost of energy with for energy storage, and so that's really been a big trend in the U.S. and I'm not sure, but probably more broadly.
Yeah, absolutely, Alex. I think that second life use of EV batteries has been a big topic, particularly in the UK, and exactly for energy storage. I think the only technology that's forthcoming, which may not feature so much in EV with regard to stationary power, is sodium ion, because particularly currently with sodium ion, which is where you started with your business, with sodium solid state. So sodium is conventionally in the bigger picture heavier and bulkier relative to the energy density. However, it's perfect for big energy storage, outside energy storage systems where you've got more space and it doesn't matter how heavy it is. But yes, absolutely. Do you see a route into even more direct storage systems with your solid state solutions?
Yeah. So we've talked a lot about kind of better economics, but the other big thing with stationary energy storage is safety, of course. So Ian's been talking about 1 megawatt systems. I mean, those are huge batteries, and with a lot of conventional lithium-ion battery technologies, if you're not careful, that's that battery has a lot of flammable material in it, and so for instance, Korea had a very big problem with this just a couple of years back, where they did up a whole bunch of grid scale installations using regular lithium-ion batteries, and some of them just started catching fire, and quite catastrophically so. And especially if it's one thing if it's a grid energy storage project, right, where it's probably like someplace out where the the distribution parts of the grid or whatever. But it's a whole nother thing if we have batteries inside of homes, right? And safety becomes very, very critical. In fact, one of the big, that's like here in the U.S. in New York City, nobody was installing any storage for a while, quite simply because no lithium-ion battery was out there that met New York City's fire codes. We're only now starting to see technologies meet those, and this is true. I think a lot of cities are now adopting the same fire codes as New York, so it's kind of becoming true across the board. And so I think solid state technology could be very compelling for in these use cases, it's again, it's a tricky balance to strike between cost efficiency and safety, but there are solid state battery technologies out there that could be quite economical to produce. And for example, something that we at Natron are really enthusiastic about is something called the million-mile battery concept. And so this is kind of an idea. This is from Professor Jeff Don at Dalhousie University in Canada. So the Don research group at Dalhousie, their whole thing is how do we make lithium-ion batteries last a really, really long time. And a lot of their research sponsored by, I think Tesla sponsors their research. They get money coming in from everywhere because of this. So, and the concept is that if you get an EV and if you get an electric vehicle, right, and you're parking in your garage at night or whatever, having that electric vehicle battery serve as battery backup to the home maybe. And so obviously and that's a massive, EV batteries are massive. They fully provide, the needs of an average household. The tricky thing is that of course you're using the battery of the EV more often, and you're going to chew through its lifespan. And so we need to expand lifespan. And so that's an interesting thing that we're exploring with our technology in particular is how can we leverage our solid state technology at Natron to get really long lifespan with certain lithium ion batteries, and how we can apply those towards something like this million-mile battery concept with EVs or towards stationary energy storage by itself. But certainly numerous technical challenges left to be solved, and it is likely. The thing is that the market's so huge. There's probably going to be some room for every innovation, and so there's almost definitely going to be room for some solid state batteries and stationary storage probably, and or at least that's our belief.
Thank you, Alex. And I think the whole safety thing raises a really, really important question, and especially your example with New York. And I know that's something Ian alluded to was the safety of the Chinese batteries, because their safety standards may not be quite as rigorous as what we have. Well, certainly sounds like not in New York, but what we have in the UK. But I understand, Ian, you're working towards being able to certify the battery packs in line with UK standards. Is that right?
Yes, that's right. It's ongoing now. It's in fact the certification has been done. It was done by a German certification company in Shanghai. So that's all already there. So that everything is okay to bring them into Europe now. We're just looking at the requirements from badging, as to what stickers needs to be on it to say don't touch here and that sort of thing. That'll be a challenge. But that's the next stage. It's just a tidy up. The product is there, it works, and it's done, it's finished. And it's a question of the legalities and the sales point of sale stuff and everything that you need to instruct people, and the instruction manual and all that sort of thing's got to be right. The Chinese are easy to deal with, really. They're quite good people to deal with, but they look at things from a China point of view, and I can tell Alex that I worked with them for 15 years on electric cars, bringing it together from a day one start of and with one of the biggest electric car companies, and just been sat in a room with 22 just newly graduated Chinese from all over the world, from Yale, Harvard, Cambridge, Oxford, Warwick. They were from everywhere. Sorbonne, they were in Amsterdam. It was quite amazing where they'd all done a variety of university educations. They were very bright kids, and we were just told that was it. We've got to make an electric car. Let's look at what we've got. Do we convert what we do? How do we start doing this? And there was at the time 7 different systems to make electric cars work. And they were all eventually ended up being, the lithium was one of them. That was just one. But there was many others that didn't make it. And the biggest problem was how to charge them fast. That was the big thing. Oh, it was
Yeah.
everything from electrolyte removal and replacing electrolytes. No, it was quite something. And I worked through that 15 years. I was going out there sort of 4 times a year and spent, you know, a month at a time over there. So I was in China an awful lot. But they tend to look. What I did discover was that their certificate, the Chinese certification, and the levels of certification is higher than Europe and America and Australia, much higher. So they're actual what they certify in China to a heavier degree than what we do in Europe, but they don't join in with the worldwide agreements like European and UK and America, where the homologation regulations for vehicles, be electric or otherwise driven, they're acceptable in either country, apart from the 1 or 2 little idiosyncrasies that we all have. For instance, we don't do a thing called a bump test here on vehicles, where you've got to hit a wall at 5 miles an hour and not cause any damage. So you can trap somebody in between 2 vehicles, and the bumpers give way, you know, the fenders give way, so that you don't break legs and things. Well, we don't do that in Europe, but they do it in America. So that's added on to the American certificate, or that you have to do that test before you can sell your car in America. But that's why we sell American cars here, and there's European cars sold in America. That's the reason. But China don't do that. China produce the worldwide agreement is all the regulations have to be in English, and they don't do that. They produce all their regulations in Chinese, and if they did it in English, there would be more Chinese product acceptable here without any more certification, because the levels of testing is higher than what it is here. So it's quite something, but they just don't do it. And we've even tried to get the translations of their work certified by the British Embassy in Shanghai to say that is what it is, but they still won't accept it unless it's top copy in English. It's not acceptable for European registration, or America or Australia, any of those kind of countries, any Western countries. So but that will change. I think somebody eventually in China will spot that, and that's when the product will start flowing much heavier than what it is now, and eventually they'll do it. But no, it's been a ride. And sodium was talked about a long time ago, but nobody in China ever took it up. They are working on it now, but nobody really went heavy into it, as far as I can recall. It was never in any of the factories, and I was working with about 7 or 8 electric car companies, doing a variety. My function was ensuring that they were homologated and they could pass the tests that were required, even the fundamental tests. Make sure they're not too wide or too short or high enough off the ground, and they had their safety tests done, because without that, nothing's coming in. It didn't matter what it looked like or what it did. So fundamental test was the first thing, and then the top line test after that, crash testing and all this sort of thing, goes after that. And that was it. That's what I did. So I'm well aware of the automotive requirements of all this, and it's been quite a journey. But then that's it. I decided that as electric cars were becoming more and more, my whole upbringing and growing up was all on diesel and petrol, and it's been that for 30 odd years before the new stuff. And the new stuff had to be sold and transported and handed to customers totally different to what I was used to. It had to be new. What it actually ends up being in the long run, I don't know. But it wasn't me. So that's when I decided to go and stay at my farm and do other things, change and decide to do other things, and then you end up back in the distribution game fairly quickly, I have to say. But that was just they asked, and I thought I'd have to give it a go. So it's been all right so far. And as we launch, we will recover the investment fund. The investment hasn't been that huge, really, because we haven't had any R&D costs. That's been done by the Chinese. So all of our stuff is just taking it from there, making sure it's right for here and going straight to retail. So that's all it is. And we're not getting involved in too much in the big industrial stuff yet, because that's you have to put a lot of resources behind that to design it, plan it, to do the CAD drawings, the electrical architecture, and all this sort of thing, to actually get the it's a lot of people involved to put a presentation together for one of those. And there's lots of them. There's lots of them. If you get one, you will do very well out of it, but you'll be there amongst a half a dozen other people, and you have to spend a lot of money to be part of the race, if you see what I mean. And that's not wise for a new company to do that. It's better to sell small and larger volume with a decent profit on it that can keep you going, and then you build up resources so that you can do play with a bigger thing. But
Yeah, thank you. And I find it very interesting you're talking about the standards in China being a lot higher. Back in the early 2000s, I worked for a refractory metals company, and we set up a company over in Shanghai, I believe. And we were absolutely perplexed by the fact that at the time, for a new company, we had to adhere to such strict guidelines, but because existing companies had been set up in the past and were operating under the conditions that they were used to, they were still allowed to operate in a very unprofessional and unsafe way. The upshot was that we were plating thyristor discs made of molybdenum, and we had this all singing, all shiny, dancing factory in Shanghai, but we had to go to a backstreet plater to get the plating done because we couldn't get the documentation to actually do the plating in our so it's really encouraging. It's really encouraging to hear that sort of 20 years later. It looks
really,
like
really high.
They've yeah, so that's fascinating. Thank you. Yeah. So I think I mean, that's been a really, really fascinating conversation. Do you have any more points you want to raise, Alex, or?
Yeah, just no, I think as far as another way that solid state could have a role with could have a role in stationary energy storage. Yeah, so one thing, this again kind of comes back to safety and economics, but like one thing that people don't realize is that right now, if you take something like a stationary energy storage battery pack or whatever, you open it up, it's not just going to be entirely packed full with battery cells. Actually, about half of what's inside is not going to be battery cells. It's just systems that are there to stop the battery cells from or try to stop the battery cells from catching fire and cooking off. So things like active cooling, battery management, electronics, all these things. And so and those are very inefficient, both from actually taking up space inside a battery pack, but also cost inefficient. And so again, so another way is that if we can fundamentally within the battery cell remove flammable liquid electrolyte material by switching to solid state, then that's a lot less work you then have to do when you put a bunch of cells together, because the safety is already there, it's inherent. And so at least and what we've been up to at NATRION, we think at least in some EV battery packs, we can reduce active cooling and BMS requirements by 20 to 30% or more. And so, and we're going to keep working on that, but that's another thing. So it's just ultimately, it's just there, by working on technologies kind of at the fundamental cell level, that's there's kind of a, I guess, magnification effect, right? Once you make more complex battery pack systems, and things become simpler and easier and better. So there's a big role for battery cell level innovations to play in stationary energy storage systems of the future.
Thanks, Alex, and I agree. I think that there are many innovations in the pipeline at the moment. I mean, in order to, as you said, reduce the amount of otherwise redundant materials that are contained within the battery pack. So I think reducing the necessity for cooling, reducing the necessity for compression, reducing the necessity for the electronics that goes into it. I mean, a lot of battery packs contain about 15% weight just in the copper used to connect the battery systems together. And I think there's which all adds to reduce the energy density. So absolutely, if and I think also one thing I've come across is smart cells, which will actually not only not only enable the individual cell to communicate with a more simple battery management system, but also will store data on a individual cell, which will then be able to instantly define its second life purpose. You know, so one of the challenges, as we discussed with second life applications. So when you were talking about taking EV batteries and putting them into stationary power, is that a lithium-ion battery at the moment that is at the second life point will require up to 2 weeks of testing in order to, or at least a significant amount of energy and time in order to determine what its state of health is and where it is best positioned in a second life application. So, you know, all of this is coming where you know, you'll be able to look at an individual cell from a battery pack that has been used in an EV, and you'll be able to instantly say, right, it's got 80%, you know, capacity remaining. We can put it in a class A, or it's got 60%. We'll put it in a class B or whatever instantly, rather than having to invest time and money into investigating because essentially that time and money could actually be displaced by just buying a new unit, which is really not what we're trying to achieve at all.
Yep.
That's good.
Yeah.
Right. Okay.
Yeah. So yeah, no, that's been a really, really useful discussion. Thank you, Ian, and thanks,
No
Alex.
problem.
I think we can probably leave it for today. But we'll be back with some more TEK-TOK within a few months. We'll probably take some time out for the festive period,
Yes.
and perhaps come back in February. But for now, it's been an absolute pleasure. Thank you
Okay.
very much, and really real pleasure to have you on the show today.
Yeah. Thank you, John. Yeah. Happy holidays.
Thanks, man.
Yeah, happy holidays. We'll talk soon, Alex.
All right.
Talk
Cheers, man.
soon, Ian, too.
Bye,
Cheers.
man.
Okay. Angela, you can stop the recording now.